One of the questions we get asked most at 3D Natives is, where is 3D printing actually being used? Not in labs, not in concept renders, in the real world, right now, by real people solving real problems. We went to RAPID TCT 2026 in Boston to find out. And what we found wasn't what we expected. 5 applications that each gave us a different answer to that question. We start with something nobody expected to find at an industrial additive manufacturing show. Marcus from Voxel Percussion, based in Ohio, builds 3D printed drum kits with the help of Polymaker. Full kits. The kick drum alone takes 6 days to print. The full set averages around 80 hours. But the reason he uses 3D printing isn't about the speed or cost. It's about something no other manufacturing process can give him. Inside each shell, he's designed a system of internal funnels and inserts that disrupt the column of air as it moves. That manipulation of geometry changes the acoustic properties of the drum in ways that wood or metal simply can't replicate. The tonality sits between metal and wood, with an added mid-body response. And because every part is printed, he can offer drummers something that was previously reserved for the most famous names in music, a fully custom signature drum, with your name printed directly into the shell. It's a one-off, no minimum run. Voxel Drums is at voxeldrums.com and on Instagram at Voxel Percussion. From a drum kit to a motorcycle. Pantheon is a company from Vancouver, now moving to San Francisco, and they build composite 3D printers focused entirely on end-use structural parts. To prove that point, they built this, the Pantheon Combo, a fully 3D printed motorcycle with a nod to the Honda Moto Compacto. The bike is made of about 100 pounds of 3D printed parts, which were made in just 10 days on a single printer. Structural components were made with carbon-filled nylon, aesthetic parts and glass-filled nylon, water-exposed parts were made with carbon-filled PETG, and the seat is made of TPU. What's really cool is that half the team commutes on these, and that last detail is the one that matters, because a commuter motorcycle isn't a prototype. It's proof that the concept moves at speed, carries weight, and handles real road conditions every single day. Their HS Pro printer sells for $35,000, and if you order enough of them, they'll gift you the motorcycle for free. Boston is one of the world's leading life sciences hubs, and that made this one particularly fitting to find here. Sailner is a Chinese medical technology company from Zhuhai, and the medical J401 is built specifically for surgical planning models. It's capable of printing 7 materials simultaneously, full color, plus soft and rigid composite in the same part, with resolution of up to 600 by 600 by 1800 dpi. Plus, these parts qualify for the National Class II Medical Device Certification. The technology is called White Jet Process, WJP, and the patent isn't even public yet. What struck us when we saw it in person was how familiar the output looked. Visually, it's remarkably close to PolyJet, but it isn't PolyJet. It's a completely separate process achieving similar results, through a different route. For surgeons, that means anatomical models with a level of color accuracy and material differentiation that genuinely changes how complex procedures get planned. At the show in Boston, that might have been the first time most people in the Western AM community saw this technology in person. This one we've been following for a while at 3D Natives. Rapid Liquid Print, RLP, prints inside a gel. The gel acts as a support, holding the silicone in place as it builds layer by layer in suspension. No support structures, no waste. And the material isn't a silicone substitute. It's real skin-safe, non-toxic silicone in direct contact with patients. What brought us to their booth in Boston was a specific application, prosthetic liners. A healthcare worker scans the patient's limb, sends the file to RLP, and a custom liner, fitted precisely to that patient's body, is printed in around 1 hour and 15 minutes. Cure time is 5 hours. And remarkably, the patient receives it the next day. For context, traditional custom prosthetic fabrication takes weeks. RLP also adds a matte texture to the outside for grip and a glossy finish on the inside for skin adhesion. Real patients are already using these worldwide, and they're working with a vascular company on the next application. This is what gravity-free printing looks like when it leaves the lab. We saved the most ambitious for last, and also the one that left us with the most questions. PanAm 3D is an American company from Pennsylvania, and what they brought to Boston was a surgical robot called the Centaur. According to the company, around 80% of it is printed in titanium using their own polar coordinate metal 3D printer, a system that 3D prints runs on a spiral rather than a traditional Cartesian system, allowing it to scale up to 8 or 10 feet in diameter. The Centaur is designed to assist or eventually replace existing surgical robotic systems. We saw the model at the show, but we didn't see it move. What PanAm is describing is genuinely ambitious, a startup combining a proprietary metal 3D printing process with surgical robotics. The company's looking into the space and seeking investment. Whether the technology delivers on everything they're claiming remains to be seen, but the vision is clear. And sometimes, at a show like this, the most interesting booths are the ones asking the biggest questions. So there you have it, a drum kit in Ohio, a motorcycle commuting through Vancouver, a surgical robot printed in titanium, a prosthetic liner fitted to a patient's body in an hour. These aren't concepts and they aren't renders. They're what 3D printing is actually being used for right now by people who decided the technology was ready even when the rest of the world wasn't sure. We'll see you at the next one.